It's honor to welcome the resource person, Dr. Sai Narayanan, Global Technology Director, HCL Tech Chennai. Welcome you, sir. His topic is Bridging the Gap, Making AI Work in the Real World. I request the chairperson to start the session.
Good afternoon to one and all. It is a great honor to introduce Dr. Sai Narayanan sir. Dr. Sai Narayanan is a Global Technology Director at HCL Tech, Chennai. He is a senior technology leader with extensive experience in driving global digital transformation initiatives across enterprise platforms and emerging technologies. Dr. Sai Narayanan has played a key role in shaping technology strategy, innovation frameworks, and large-scale solution delivery for international clients. His expertise span cloud computing, data analytics, artificial intelligence, and enterprise architecture. With a strong focus on innovation, operational excellence, and leadership development, he actively contributes to building future-ready technology ecosystems and mentoring high-performing global engineering teams. Today, he is here to enlighten us in the topic, Bridging the Gap, Making AI Work in the Real World. With these short notes, I invite Dr. Sai Narayanan sir to deliver your valuable address. Thank you, sir.
Good afternoon all. Let me start the talk directly. I think I'm standing between the lunch. I see most of people are already have started the lunch, right? Okay. There is an interesting previous panel discussion. There's a lot of deliberation on the AI, what is possible, what is not possible, right? I concur and I differ in things. Let me address in my talk. See, when it comes to AI, right, this is a transformation what we have gone through. Earlier it was machine learning, then we had a deep learning, then we have a generative AI. The one main difference is like the machine learning, deep learning were very deterministic. You know what you get. It is easy to evaluate. We know what we give input to it. But generative AI is not like that, right? It is a probabilistic, and we don't know what the input it has gone through. And I really like the previous session's question, like whether like if you are given a wrong input, what type of output we will get. Yes, if you give a wrong input, there is a high possibility you get a wrong output, because like and we don't know whether the input gone in, because how these GPTs are trained is on all the open internet data, right? It is not always all the internet data are right. Right? So there is always a challenge, right? The main challenge what is we are facing, how to evaluate these AI models. It itself is a big challenge. And that is a big opportunity. As an type of a multidisciplinary university, you can always come up with the ways to evaluate the accuracy or the way you evaluate your AI models in a medical domain or any specific domains. And there is an opportunity to build more reliable as well, right? So that is a challenge always you have with this generative AI, right? When coming to the application, right? It is entering everywhere. I will say it enters everywhere, right? Right for software development, right? And customer service or any conversational system we have, right? And automation, everywhere it is penetrating. And I really appreciate the point, like we talk about agentic AI also, right? It is like it is getting, it's able to interact with multiple systems and able to suggest or able to solve. But the challenge what we have, can we leave it in an automated way? Yes. for a low-end type of works, right? Wherever like we are like simple works, we are able to do it automatically. But what the one extreme of it is a medical diagnosis, which is a high complex, lot of human intelligence or which manner. We see it many times. And there is challenges. You ask the same question 5 times, you will get a 5 different answers also. Right? That is the inherent way the mathematics built behind this AI will behave like that. And it is for us to see that how to verify, and there are techniques to do. There are techniques to do to validate. There are techniques to check, control these hallucinations, right? But the main problem what we have, AI is hallucinating. That is one side. Humans are hallucinating more than AI now, because there is a lot of marketing articles in the internet, right? Talks about doing magic and other thing, but that is not the real case, because how the AI is wired, right? If you see it, if you go to the low-level algorithms of it, right? It is a probability. End of day, what is a probability? Closer is what it does it mathematically. So it is going to be a probabilistic output only, right? So let me tell about the challenges and opportunity. There are a lot of areas which have enabled the AI. Like in terms of connectivity, we have a very good 5G connectivity. Data securities are in many encryption algorithms have come. The softwares, all right, the partitioning of softwares, right? What can run in a hardware, what can run in a software, what can run in a native edge devices. There is a lot of development have come in. But the challenge, and computing also, we have a cloud, right? We know you ask some questions in your mobile, there is some computing happens in your mobile, some happens in the cloud. So there is a partition. Now things have matured, software has matured to partition your computing, which to run locally, which to run. And it is also scalable. Right? It can scale like horizontally, vertically, you can get your computing done. But that is not a form factor. Due to the growth in the semiconductor technology, things are becoming smaller. Right now, things are there. You can carry a hardware, language model hardware in a packet. That is, things have come. But it's not all language models. Some smaller models you can carry. But main challenge has come in how you compute this AI. Right? That is a big problem what industry is facing. If we can solve how you compute because the way the algorithms or hardwares are written are not for computing AI. This all are written, mainly we talk about GPUs and all, these are built for gaming industries. Like instead of having few cores, right? If you have an i7 machine, it may have a 8 core, means you can do 8 different operations parallelly. That is what core. It's an 8 computers like that. But the GPUs will have 4,000 or 5,000 computers inside, right? It can do so many parallel operations. But these parallel operations are built for doing rendering of images, right? Rendering of this gaming. But this has been repurposed to use it for a AI. But now demands are more. Then the new hardwares are evolving. But still there is a lot of scope. I'm not going to touch upon on the generative AI where it is being used in healthcare, but the doctors here are more aware of it. They are able to tell different use cases, right? One thing I can tell, the usage are more where you are not able to consolidate or interpret, bring insights from the data, right? This is useful, right? This is useful, you can get it. But again, a validation is important, and don't rely on a direct ChatGPT. Just sending a prompt and coming out, right? It can be only 60-70%, it can be accurate. We have to build reliability on top of it. We have to build security on top of it. We need to know when we send the data, we need to know what this data they are going to use with that, right? That is again that we need to understand the data policies, which are like a secured endpoint is we are using, because it is a very serious thing. Like people don't want to send the data. It is not the value of the data, it's the privacy of the data, right? So those type of things are which the medical industries are to be aware of it, to be like a thing, not sending the data into a general open-ended GPT platform. It is not a proper way to do. And in terms of the market, it is going at 40 to 50% of CJR we are seeing in generative AI application. But again, like the problem is accuracy, right?
it's still a challenge, right? We even we get a type of an agent, or we get it. Agent is nothing but it is not a new technology. It is there for 25 years, agents and all. But we are combining the agents with AI. That is what is happening, right? So I'm skipping here. The core capability is it can understand language. One different thing, the core of this generative AI is it can understand language, it can generate language, right? And it can understand multimodal, it can understand image, voice, type of things. How we are going to bring it here? The one thing, what the promising thing, bringing some explainability into it, means you take a decision, how you have taken the decision, right? If we can have a thing to validate it, the explainability, or how the AI is making decision, that will help to improve. So I'll skip this applications and all. Yeah. See, a simple calculation I just want to give. If we are doing a type of an image understanding, or we are doing anything, how much of calculations you are making, that is huge. If you are taking and once, say, we call it as a floating point operation, means you add two number or you multiply two number, that is one calculation. If you are going to use a simple like a deep learning model, it is doing about a teraflops of operation. Tera calculation has to happen within 1/30th of second, right? That is a huge problem, and it's a huge challenge as well. These are the complexity of AI. Like you get your data is not sequentially flowing. The data is like the memory, whatever the memory requirements, whatever the memory model we are having, those are like not fitting or not enabling this AI computing. So the challenge what we have to do, then we have to come up with our own computing platforms. But again, the problem is, if we take about a normal language models, it will have billions of data, and you have to load this data and do the calculation. But the memory availabilities are very, very limited. And if you are going to read into the memory, write into the memory, it is going to take energy. It is going to give out the heat outside. So the cooling of AI system itself is a big problem. People are right, cooling technology, they are cooling at the chip level. Cooling technology have come, right? And if you are sending one query to ChatGPT, like one question you are sending, we are releasing 3 to